All right. All right, so good morning, everyone. I'm Mehek, and I'm going to be your room host for today. Before we get started, I would just like to acknowledge the Gadigal people of the Eora Nation on whose land ICC Sydney stands on, which we meet today, and I pay my respects to their elders, past and present. Just some housekeeping rules before we get started. If everyone could just make sure that their phones are silenced throughout the presentations, it'd be really great for all of the other audience members as well. Also, all of our sessions are being live streamed and recorded, and they will be available after Sydney Summit. Now, our first session for today is going to be a Level 200 session, and you're in the right room if you would like to know more about the innovative ways Spatial Services reduced processing times by over 1,000% using AWS. So our session for today is From Days to Hours, How DCS Spatial Services Enhanced Emergency Response. Without further ado, I'd like to call on stage Cara Lyons.
Good morning and welcome. Thank you so much for attending. So like Mehek said, today you're here to hear about how the Department of Customer Service Spatial Services enhanced emergency response by reducing the data processing time from days to hours. Something that would not be possible without the scalability and the elasticity of the cloud. So I'm Cara Lyons, I'm a Principal Solutions Architect at AWS, and I'm joined here today by Katie Peters from Spatial Services. So what we're going to cover today is we're going to talk about the current data landscape and how that is really important for this story. Then we'll hear about the Spatial Services transformation journey and the mission-critical outcomes that they achieved in the process. And then I'll talk about some of the innovative ways AWS technologies were used to support those outcomes. So let's talk about the evolution of data. We are experiencing unprecedented data growth over the past few decades. And this exponential growth in data presents both challenges and opportunities for organizations. We're also experiencing a rate of technology evolution like never before. So global data has grown 22% year after year between 2010 and 2025. And 90% of this data is unstructured data. So that's things like files or images, for example. I recall in the early 2000s my cutting-edge digital camera, and I was storing images, maybe 1 or 2 megabytes per size. But today, organizations like Spatial Services operate high-quality LiDAR sensors in their planes. They capture imagery and elevation data. They cover the area size of Singapore, and a single run can generate data up to half a terabyte. So you can see how this changes the way we need to store and process data to achieve our business outcomes. This is an example of an image captured from a Spatial Services plane with some infrared overlay. So in today's digital landscape, we're seeing that when you remove the limitations on infrastructure, you remove the limitations on innovation. And companies across all sectors are building without limits in the cloud. So what was once impossible is not just feasible, but transformative. But this is not just a story about data or technology. A successful business transformation exists at the intersection between people, process, and technology. And all three must progress in parallel. So Katie will walk through the people and the process journey that Spatial Services embarked on, and I'll talk through some of the innovative ways the technology supported those outcomes. But now I'll hand you over to Katie to hear about the Spatial Services transformation journey and the mission-critical outcomes that they achieved. Thank you. Thanks, Katie.
Good morning, everyone. I'm delighted to share the story of how DCS Spatial Services redefined what's possible for public sector innovation. Spatial Services is the state's authoritative source of geospatial information. Our foundational datasets, like land boundaries, place names, and elevation models, underpin infrastructure, urban planning, and emergency response for more than 8 million people across New South Wales. If you work in the public sector, you will know that transformation is often hard and slow. Too often we're stuck maintaining rather than modernising. But today I'll show you how we broke that cycle, moving at a pace more commonly seen in the private sector. In just 10 months, we delivered a global second proof of concept, modernised our broader systems, and delivered huge value to spatial services. Our journey shows that even the most complex organisation with the right partnership, leadership and capability can deliver the most transformative outcomes, which was evident after the New South Wales bushfires in 2019. It's really important to understand why our change was urgent. The New South Wales bushfires were devastating on every level. Over $1 billion of infrastructure was lost. More than 2,500 homes were destroyed, and most tragically, 26 lives were lost. All major inquiries after the event made it clear New South Wales needed faster, more reliable access to emergency data during emergencies, and that's the problem we set out to solve. So we had two main goals. We needed to develop a rapid response imagery and elevation processing pipeline, and we needed to modernise our broader spatial maintenance and delivery systems. So we needed to build for today's urgency, but also for tomorrow's resilience. So we began by working backwards from the outcome we needed. When there's an emergency, our planes are deployed and they capture aerial imagery. Then we need to ingest, process, store, and deliver that data within 24 hours. When we deconstructed the problem, we realised it wasn't just one problem, it was the entire pipeline. Our sensors produce the most incredible high-resolution, high-res imagery. It is honestly the most incredible, high-detailed imagery. But this comes at a big cost, huge data sizes. And this problem is not going away. Our data is growing exponentially. So our challenge was clear. How do we deliver more data faster than ever when our on-premise systems are already overwhelmed? So we started small with an in-house proof of concept. Our cloud engineers and GIS specialists modified our workflows for cloud. There was a lot of trial and error, but it gave us the flexibility to learn quickly and adapt the solution. So we put our pipeline to the test. We simulated a worst-case rapid response scenario. We processed nearly 700 square kilometres of aerial data, which is roughly the size of Singapore, captured in just 5 hours. This was to stress test our system and put it to the max and see what it could do. Then we compared cloud processing directly against our on-premise systems. And this was the turning point. We had incredible results. Processing overall was 1,200% quicker than our on-premise systems. For some of our most complex parts of the pipeline, we improved speed by 3,000%. What was taking a day normally was now just taking under an hour. Cloud processing lets us scale up instantly for emergencies and then scale back down for everyday work. This flexibility means that we're only paying for what we use. We were the second globally to achieve this, and that success gave us the confidence to partner with AWS Professional Services and AWS partners. And I'm proud to share that this work was recognised with the DCS Excellence and Innovation Award, a testament to the leadership and impact of our people. This is an example of some of our near-infrared imagery before and after the floods. So, what about our broader transformation? This project wasn't just about technology, it was about our people. Self-service cloud gave teams the autonomy to deploy and manage the environments. Standardized workflows brought consistency, speed, and scale. We were faster and now more consistent. This was a cultural shift towards agility, autonomy, and continuous improvement. On the technological side, we've significantly reduced risk and improved performance, and we've introduced real-time cost control. This means we can now adapt and grow rapidly while maintaining stability and security. What used to take weeks to build can now be deployed within hours. So overall, this gives us greater operational excellence and reliability, improved cost control and visibility, and flexibility to scale and grow as our business needs change. And ultimately, this has positioned us for long-term innovation and leadership in how we develop and deliver our spatial data services. So what made this transformation work? Let me share 5 key lessons from our journey that helped us achieve all of this. Let's walk through each one. First and foremost, AWS were a trusted co-pilot, not just a vendor. From day one, they embedded their specialists in our teams to help us problem solve and rethink our architecture. They understood the complexities that can come with working in government, and they were able to flex with it, which made things so much easier. And most importantly, they helped build our internal capability, not dependency. So the key takeaway here is a great partner doesn't just help you deliver, they help you grow stronger in the process. Number 2 was communication. Communication wasn't an afterthought, it was a core part of our strategy. We knew that we needed to make change relatable and fun, to make it easier to understand. We looked at this like we were going on a journey to cloud. So we had an airport-themed comms hub. We had boarding pass surveys, which helped to capture requirements and gather feedback. We even had in-flight entertainment, which were actually our training videos. So we knew that we needed to make this transformation clear and engaging, not just have code. It needed to feel accessible even for our non-technical teams. And the result from doing this was that we had higher trust, less resilience, and stronger ownership. When the story is easy to understand, the change is easier to embrace. A big part of why we were able to move so fast was that we led the proof of concept ourselves. Our geospatial workflows are niche and complex, and out-of-the-box solutions just simply wouldn't work. Leading the proof of concept gave us the freedom to experiment, fail, and iterate quickly. Now, this might all sound like we went from A to B very quickly and very easily, but when in reality, we went from A to B to C to D to E to F to G. It was very challenging and hard, and it was a real lesson in our determination and resilience. But it gave us the flexibility and freedom to fail, which we just wouldn't have been able to do if we had have brought the partners in too early. So then, once we'd had the success, we were able to partner with confidence, knowing what we were trying to build and why. So that, combined with Agile for speed, and using guardrails like FinOps and best practices really helped us stay in control. So we had best practices built in from the very start. We were really trying to design with the future in mind. And all of these best practices were baked in from the very beginning. So we were able to move fast yet stay in control. And last of all, we didn't just build a system, we built the capability to run it ourselves. Our teams are trained not just to operate the system, but to own it. Today, our people own, improve, and evolve the system like they're innovators, which is really exciting. And this is ultimately driving long-term sustainable value. So we came out of this much stronger and less dependent. So our cloud journey continues at Spatial Services. We're not just better at processing imagery, we're better across the board. What we've built is repeatable and sustainable. Our foundation is built and the future is ours to shape, which is really exciting. But we aren't unique. What we've been able to accomplish isn't a one-off. Our journey shows that with the right blend of partnership, leadership, and capability, even the most complex organizations can deliver transformative outcomes. And you can do this too. I'm going to pass you back to Kara to walk you through the architecture. Thank you.
Thank you, Katie. It's been an honor to be part of this transformation journey with you. But how did our AWS technologies support this outcome? What AWS services, what design principles did we use to support this? So I'm going to dive into the high-level architecture. This is not too scary, hopefully. So first of all, this solution supports business-as-usual use cases as well as emergency response scenarios. But let's break this down further. So first, the imagery and elevation flight data that is captured from mass media drives is uploaded to Amazon S3 bucket in its raw format. So Amazon S3 is our highly durable, performant, scalable object storage solution, and it's ideal for unstructured data. Then our business users launch data processing jobs through AWS Service Catalog. So this supports the management of approved IT resources. So things like virtual machine images, servers, databases, software, and more. So the infrastructure is defined as code, and it is launched from a Service Catalog portfolio. So this enables business users to quickly provision IT resources without relying on the underlying AWS services or on the IT teams. It also facilitates a self-service culture and shifts the control to the business users. This then triggers the creation of a per-job environment. So each data processing job has its own IT resources. This prevents resource contention between job activities, and it also facilitates independent monitoring and reporting. And you'll notice that spot fleets are used for the compute. So spot fleets are designed to be a way to launch tens, hundreds, or thousands of Amazon EC2 instances in a single operation. These virtual servers are taken from Amazon's pool of spare capacity, and they offer discounts of up to 90%. Each job scales to meet the demand of the job requirements, so the compute is distributed across a range of nodes. So you can see how this is a very cost-effective, efficient way to process the data. Once the data is processed, the compute is no longer required, so that's terminated, and then the data is written to another long-term storage in another S3 bucket. And there it can be consumed by other business users or emergency service organizations. And all of this is done in a zero-trust environment. It adheres to all the government security and compliance standards, such as Essential 8. It's also monitored using Amazon CloudWatch. Each job is assigned metadata. So it has its job ID, its business unit, the cost center, and so on. And AWS Cost Explorer allows you to visualize your AWS costs and usage. So combined with the captured metadata, business users can now see each job's cost, usage, and performance. So spatial services have a cost per job capability. And this is also really useful for organizations looking to implement a chargeback mechanism for different departments or workloads. And all of this aligns with the well-architected framework. So this is a set of guidelines and best practices for designing and running workloads in the cloud. And the constraints that we used to have in the on-premises environment no longer exist. But I wanted to talk through the top 5 strategies that helped make this a successful project. So the first winning strategy was the self-service capabilities. So this heavily aligns with the operational excellence pillar. It removes the reliance on the IT platform teams. The infrastructure is automated. It also aligns with the security pillar. It uses fine-grained permissions, and users are only allowed to launch approved IT resources. Our second winning strategy was the use of spot fleets. So heavily aligning with the cost optimization pillar. As I mentioned, you get 90%, up to 90% cost savings by using Amazon's compute from a spare pool of capacity. And also, you'll scale to meet the demand, so it's highly performant. The third winning strategy was the tagging strategy. So by assigning metadata to the individual resources, you can create a very sophisticated financial governance model. So this would be music to any CFOs in the audience here. The fourth winning strategy was the automation of the infrastructure. And this aligns with several of the well-architected key pillars. So by automating infrastructure, you have that repeatability, you have the standardization for each of the job processing data options. It also allows you to recover from failure in the event of a disaster. And the fifth and final winning strategy was the auto-scaling capability. So aligning with most of the well-architected framework pillars, by dynamically assigning resources to meet the specific job requirements, you're heavily cost optimized, it's highly performant, and also you reduce the unnecessary compute, and therefore it's sustainable. So it was a combination of all of these 5 strategies that helped achieve the successful outcome. And so Spatial Services reduced its data processing time from days, actually, to hours. It's also important to note that none of these strategies would be available in a traditional on-premises environment. So be bold, think big, and start small. We have seen how a successful business transformation exists at the intersection between people, process, and technology. Stakeholder trust is imperative, and we have learned how storytelling can be a way to garner that trust. Lead with a strong vision, and take all of your teams on the journey with you. Invest in your people. Ensure they have the skills, the tools, and the processes that they need to help achieve your business outcomes and offer that continuous improvement. We have things like Skill Builder. They offer 600 free online digital courses, or you can get subscription access to more premium content. And utilize AWS professional services and/or AWS partners. This can really help you accelerate your cloud journey and even upskill your internal organization teams. But this is not just about processing imagery and elevation data. There's a myriad of use cases that follow similar patterns. So these are seasonal or periodic use cases that require the elasticity and the scalability of cloud. They are temporary workloads that don't require access to persistent compute. So some examples might be running your end of financial year calculations or your monthly payroll processing. It could be spinning up compute for vaccine development modeling. It could be running jobs for movie encoding for different files or formats or resolutions. Or it could be running the end of year or end of term online exam sessions. So if you have a use case that follows any of these similar patterns, perhaps you can take away some of the strategies that we've showcased here today. And with that, I would like to thank you, Spatial Services, for sharing the transformation journey that they embarked on and the mission-critical outcomes that they achieved. If you have any questions about any of these, we'll be at the back of the room after this. But thank you so much for attending. Thank you for your time, and enjoy the rest of your summit. Thank you.